Hi guys, welcome back to my channel Pirai Academy. In this video, we are going to see about Leetcode question number 162. Find a peak element. So a peak element is an element that is greater than its neighbors. Okay, given a zero-indexed integer array nums, find a peak element and return its index. If the array contains multiple peaks, then return any index. Okay, fine. You may imagine that nums of -1 is equal to nums of n is equal to minus infinity. In other words, an element is always considered to be strictly greater than its neighbor that is outside the array, which means in its corner, if there is a value, then that value is always greater than its next or previous in this value. Okay, in a corner, I'll be telling what it means. Okay, in the drawing explanation. Okay, fine. Now just see this 1 2 3 1. Okay, now here I can tell you that the peak element is going to be 3, because we can directly see here 3 is greater than 2 and also greater than 1. Fine. Okay, now here in this second example, I can tell you that this 2 is strictly greater than its neighbor, and also the 6 is strictly greater than its neighbor. So you can either return 1 or you can return 5, because that's the index value, right? Okay. So let us get started. See here, what I'm supposed to say is, just see this particular example, 6 5 1. Here I can tell you that the 6 is greater than this 5. Okay, but you may arise with some doubt, like whether the 6 is greater than its left side, which means its previous value. There is no previous value, right? Then we want to take like minus infinity. So 6 is absolutely greater than the minus infinity. So I can tell you that the 6 is going to be the peak element. Similarly here also 6 is greater than 5, also greater than minus infinity, because there is no next value. Now hence you can tell me that here 0 is going to be the result, here 2 is going to be the result. Hope you understand this. Now what is the immediate answer we are going to give here by using the brute force approach? I'll be traversing all the elements and checking whether its neighbors or whether strictly lesser than the particular value or not. For example, first of all, I am standing here 1. So whether 1 is is greater than its neighbor? No, because here is 2. Okay, so 1 is lesser than 2. Okay, now standing at 2. 2 is greater than 1. Is greater than 1, but 2 is not greater than 3. So it is also not a result. Now 3 is greater than 2. Okay, 3 is also greater than 1, which means this is going to be a result, and result is going to be 2. Fine. So it is a easy brute force approach. So what is the time complexity? It will be O of n, and what is space complexity? It will be O of 1. Fine. Now let us go to the next thing, next approach, whether we can optimize this approach. Okay, so see here, this is the given array. Now here this is one of the output, or we can also output this, because these two things are greater than the neighbor. Okay, so before getting into this approach, we want to know about some basic understandings. Okay, so see here, I just drawn those things. So for example, there is an array that containing 1 2 3 4. What is going to be the answer? 4 is going to be the peak value. Okay, now 1 2 3 1. Here 3 is going to be the peak value, right? Like that. Okay, now see this chart here. If I am standing at this particular point called 2, okay, now where should I go? Whether I want to go towards the left side or whether I want to go towards the right side. So you have two choices, right, for any elements, because 2 is not a peak element for sure. Whether we want to go towards the left side to get the peak element, or we want to go towards the right side to get the peak element. I want to go towards the right side, because there is a guarantee of getting the peak element, right? This 4. Okay. Now I am standing at this particular point 2. Now again, where should I go? Whether towards the left side or right side? Towards the right side to get the peak value. Okay, if I am standing at the particular index called this index, this value 1. Okay, now where should I go? Towards the right side or left side? Right side, there is nothing, right? So surely I will be going towards the left side and getting this peak value. Okay, fine. Let's see more observation. So see here I am standing at this 2. Whether I want to go towards the right side or left side, you may go to the left side, you will be getting this peak value. or you may go to the right side and you will be getting this peak value. Can you understand this? Okay. Now come here. I am standing at this 2. Where should I go? Towards the right or towards the left? I will surely go towards the left because 5 is there, right? So from these all observation, what is the common observation I have made? Whenever I am standing at a particular point and I want to make a decision whether I want to go to the left or go to the right, or I want to just return that particular value because that may be a peak element also, right? For example, I am standing at this particular point. It is a peak element. Okay, so we cannot decide roughly, right? So where should I go? Whether I want to go to the left or right? Okay, that's going to the confusion, right? So from these all observation, I can understand that whenever the curve rises, whenever the chart rises, that side I should be moving on. For example, if I am at this particular point 2, then I want to move towards the increasing side, which is going to be the right side. Okay, if I am standing at this particular point 1, then where should I go? I should be going towards the left side, because that's going to a rising curve, right? Now I am at this particular point 2. Now listen this carefully. I am at this particular point 2. Now where should I go? I should be going towards the increasing side. You may also argue, hey, you must go to the decreasing side so that you can get this 2 also. But it is not in every cases. It is not in every cases, because in some cases it is not possible. For example, if I am standing at this particular point, if I go towards the lesser value, I don't get it. If I go towards the greater value, I will be surely getting it. Can I understand this? If I am going towards the greater value, I will be getting at the edge corner value, or I may be getting the peak value which is greater than its left and the right side value. For example, see here it is 2, right? Now if I go into the greater value, this 4 is not a peak element, but this 5 is peak element because it is a last element and it is surely greater than this previous element also. If I traverse like this, can you understand this? So that's the reason why whenever we are standing at a particular point, we must going towards the increasing curve. So if I'm standing at this 20, I'll be going towards this right side value. Okay, you may also go towards the left side, but it is not guaranteed. Whenever I am going towards the increasing curve, it is surely guaranteed, right? So now from these observations, I can tell you that we can go with the binary search approach. You may ask how we are going to do a binary search approach. Let me take this and paste here. Okay, now if you don't know about the binary search approach, just go and watch the binary search introduction video where I will be telling you how to do a binary search. Okay, fine. So see here, initially I will be pointing a L pointer here and U pointer here. Okay, now what is the mid? Mid is going to be this 3, right? Let me put the index values. Okay, now mid is going to be the 3. Okay, now for this 3, whether it is a peak value? No, because 3 is not greater than this 5, right? Okay, where should I move on? Okay, just compare. What is this? It is 1. 1 is lesser than 3, which means I should not move towards that side. Why? Because it is a decreasing curve. Whether I want to move towards the right side, it is 5. 5 means it is increasing curve. Surely you want to move towards the right side. If I move to the right side, it will be L is equal to mid plus 1. So I will be moving here. Now again, what is the mid value? Mid value is 6. Okay, 6 is peak value. Right? So here I will be returning what? 5 as my answer. Okay, so let us go with another example so that you can clearly understand this. So see here, let us take 1, 3, 2, 1, then 4. Let us take like this. Okay, fine. Now what is my L value? My lower limit will be here, my upper limit will be here. Okay, and for any array, there will be surely going to be one peak element, right? Until or unless there is all the elements that are equal values. Can you understand this? So see here, if this particular value is 1, 1, 1, 1, then there will be a peak value. Sorry, there will be not a peak value. For that reason, they have clearly stated here, nums of I is not equal to nums of I plus 1 for all valid I. which means what? Which means all the neighboring values will be not equal. So this is the guarantee they have given here itself. So we can proceed with our approach. Like there will be no such case in which it is impossible to have a peak value. Like if it is like this, what is the peak value? There is nothing, right? There is nothing. So this case will be not occurred. Like they have given that no two neighbors will be same, like this. Here 1 comma 1, right? So it is not a case they have given that. Fine. Okay, now come back to here. So mid is going to be 2. Okay, now whether 2 is a peak value? No. Now here it is a down, here it is a up. So where should I go? Towards the up curve, towards the up curves, because 3 is greater than 2, right? So go towards that. So to move towards that, you will be making u pointer to mid minus 1, u pointer to mid minus 1. Okay, now again, what is going to be the mid? Mid is going to be this 1, right? Now whether 1 is greater than its neighbor. So 1 is not greater than this 3, but it is greater than its left neighbor because it is a corner value. Okay, now what should I go? Where should I go? I'll be going towards this 3 because it is an increasing curve. Okay, so L is equal to mid plus 1. So it will be here. These two pointers will be lying in the same point. So the mid will be what? This 3. Mid will be this 3. Okay, whether this 3 is greater than its neighbor? Yes. So I'll be writing what? 1 as my answer. Can I understand this? And also to just write the code for this, there is some difficulty we are facing, because whenever it is like, whenever we are standing at the index 0 and checking for its peak, checking for its whether it is a peak element or not, we want to check whether it has a left element or not, like I minus 1 and I plus 1. For example, if this is I, then I want to check whether it has I minus 1 or I plus 1, then only I want to check for its peak value, and also for comparison also. So for that reason, I will be first of all checking for whether my nums array. So this is going to be nums array, right? This nums array size is what? From 1 up to 1000. So here itself I will be checking whether my nums length is equal to 1. Then there itself I will be returning what? 0, because there is only one element. If there is only one element, then there itself I can tell you that the index 0 will be my answer. Yes. So this is the base cases. I am talking about the base conditions or edge cases. Okay. Now what is the next case we can have? So after this, we have a next case like nums of 0 maybe greater than nums of 1. At this particular point, I should return 0. Okay, and next case, nums of last is greater than nums of last minus 1. So at this condition, what should I return? The last in this value. That's it. So these three should be done. And next, where should I set my lower pointer? I should be setting my lower pointer to 1, and upper pointer should be set to last in this minus 1. So here I am telling, like, if I am having a value like this 1, 2, 1, 3, 5 like this, okay, then I'll be first of all checking whether this 1 is a valid or not. For this, this 1 is a peak element or not. For this, what should I check? I should be checking with the 0th index comparing with the first index. So whether 1 is greater than 2, no. At this point, I will be just not returning 0. Okay. Now, I am checking whether this 5 is greater than its neighbor 3. Yes. At this particular point, I will be returning 4 as my answer, because the 4th index, right? So, for example, if it is not 5, instead of 5, let me take this as something like 1 again. Okay, 1 again. Now, I will be checking whether this 1 is a peak element. No. Whether this 1 is a peak element. No. Whether this array contains only one length, which means only one element. No. At this point, I'll be making my L pointer to here and U pointer to here, so that I don't want to go to these edge values. When I am going to this edge values, I want to check whether it has a previous value or not, and here I want to check whether it is a next value or not. In this case, you want to do plenty of conditions, right? For that reason, I'll be taking only these these values and pre-checking these two values in the edge condition itself. Fine. Now tell me, what is the time complexity? So time complexity will be O of log n, because I'm using a binary search approach, and what is space complexity is O of 1. That's it. Okay, so let us see the code so that it will be more clear. So see here, this is a Java code. If you want C++ or Python code, just go and search in the description. So see here, this is a brute force approach. First of all, I am checking whether the length of the array is equal to 1, or the 0th index value is greater than the first index value. Then what should I return? I should be returning 0 as my result. Else I will be proceeding with the brute force approach. What is the brute force approach? I will be standing at the index number 1. I will be going up to nums.length -1 and then checking whether it is the particular index is greater than its neighbor or not. Okay, if it is so, I'll be returning I. Okay, or else at last I will be checking whether my last element is greater than its previous element. If it is so, I'll be returning my last index value. Can you understand this? So this is what I have told you at the last thing. Like if I don't put these two conditions, then here you want to do like whether it is a previous index or it has a next index. So there are clumsy conditions, right? So that's the reason why I told you that without using these two lines, this and this condition, these two conditions, you can also proceed with this, but still it looks clumsy. Okay, so let me submit this. Yes, it is submitted successfully, but still we can optimize this approach, right? So let me optimize this. See here, this is the optimized version code. So here I'll be first checking the edge case. Okay, these two edge cases. Okay, fine. Now let us proceed with the binary search. So here L is equal to 1 and U is equal to last -1. Okay, and then while L is less than or equal to U, what should I do? I should be start checking with this, right? So here definitely we will be having a peak element. So here itself we will be returning some value. Okay, now what is the mid value? Mid value will be L plus U minus 1 divided by 2, as you know. Now if my nums of mid is greater than nums of mid minus 1 and nums of mid is greater than the nums of mid plus 1, which means it is a peak element, right? So at that particular point I'll be returning the mid value. If the mid value is lesser than the mid plus 1, then I can tell you that there is a curve in the right side. There is an increasing curve in the right side. So move my L pointer to mid plus 1. Else I can tell you that the increasing curve is in my left side. So I will be moving my my U to mid minus 1, my upper limit to mid minus 1. Okay, so there is a dummy return -1, because in Java you want to return at last. So that's the reason I am doing a dummy return. And know that for this conditions, okay, for these constraints, you will not don't ever get this -1 as your output. I already told you, because there is no two values or no two neighbors with the same values. That's the reason why we don't ever come to this particular line when execution. You will be finishing in this looping itself. Let me submit this. Yes, it is submitted successfully. To know about these kinds of algorithms, just go and search in my YouTube channel. And if you really like this video and subscribe to my channel. And if you have any doubts, just comment below. I'll be commenting out the answers. Thank you.